That's fine. I don't care. Okay, my eyesight is very bad. Okay, so thank you, ma'am. This is yours. All right. So here you should absolutely know this.
I'm gonna move.
So definitely you should know generation time and the different types of the cell division in bacterial forms, biofilm, advantage of biofilm. And remember, we have talked about this. Now, remember, there will be problems based on this. Remember this? Yes or no? We have two types of problems that have been given to you in your PowerPoint. Yes, there were two sets of problems. So you should know that. Okay, now here is in a closed system. This is typical lag phase, log phase, and then finally the stationary phase and the death phase. Continuous culture, what's the difference between continuous and closed? Okay, so continuous, you're constantly adding and removing the spent media, right? All right, then finally we come into media. All right, very, very important. So defined media, complex media. So defined and complex is there. But then there is also selective media. There's also differential media. So what is enriched media? So defined media, complex media, enriched media, selective media, differential media. Selective and differential, many media are selective as well as what? Differential. Okay, and McConkey is good example, mannitol is a good example. So you'll be using, what's an aseptic technique? You'll be using the word aseptic technique many times. All right, how do you transfer, or how do, this is the liquid culture, you just keep that with you, sir, because this is, I'll be asking you to grade it yourself. Okay, because that's exactly how I'll be grading it. Okay, so here is streaking. Now more than the lecture, you should know it in the lab, of course. Yes, so these are things, but if I ever ask you, you should know it. Now how do you do, like this would be a good one, how would you know, how would you count the number of cells? Well, you can do the microscopic method, but in this case what happens is that you literally kill the cells. Okay, but if you want to do viable cell counting, well, what are the two methods? The two methods, like I can ask you this, a fill in the blank, good fill in the blank question would be, how would you do the viable counting or viable cell counting or microbial cell counting? Name me at least one method. So if you name me two methods, what do you get? Bonus points. Does this make sense?
So if we name both spread plate
and pour plate, then you will get bonus points. Okay. So here is serial dilution. You should know this. What is serial dilution? Now, usually now we do, instead of all this, we use the spec. This is something that we are going to be using all the time. So what does spectrophotometer measure? Well, spectrophotometer measures the turbidity. What is the usual, this is the OD that we are using. So the OD that we are using is 540. This is the usual one that we look at, all right? Because you set it at a certain OD, and then you measure the light, okay? The scattering of the light, right? So the light is passed through and you are measuring it out here through a sensor. Okay. Now we are coming important. So here is my classification. So more than my classification, remember what I said is that I definitely want you to know what are the adaptations. Everybody will want you to know adaptations. Whether you do it here or whether you do it for any biology, what are the adaptations for flight, what are the adaptations of parasites, anything that you have to absolutely know. So what are the molecular adaptations? I'm going to put a double star mark in here. In fact, I'm going to get carried away, put 4 star marks. Okay. If you are a hyperthermophile and thermophile, well, what is the adaptation? Notice that this is a repeat of chapter 2, yes? So we've stressed on that. Here it explains it even better, that whatever protein it is, it has to be very, very tightly bound. It has to be very, very tight, okay? It cannot be loose, it cannot be floppy. For a psychrophile, the protein, you will see lots and lots of alpha helices so that they are very flexible. Okay, so here if you are acidophile or alkaliophile, remember then what are the cytoplasmic pH and buffers that obviously you will be having that. Now halophiles, what do you need? You will have something called compatible solutes. A good example of compatible solute would be glycine betaine. There are many others, but glycine betaine is one which is very common all over the place, and it's found mostly in halophile or xerophile. What are xerophiles? That live in deserts, very little water. Very important, of course, this experiment. In here you are seeing what are anaerobes, aerotolerant, obligates, microaerophils. These are this is important, okay? So here I'm going to put a double star mark. And this experiment, of course, you'll be doing this in the lab. Now, why is oxygen toxic? You are going to be learning the toxic form of molecules as well as the enzymes that help to combat. So, for example, if you have peroxides, to combat that, you have catalase or you have peroxidase. For superoxides, you have superoxide dismutase. And then for hydroxyl radicals, of course, you have so many of your what? Your vitamins are very important. Keep that in mind. Then sterilizing. So there is, of course, the heat sterilizing, that you have the hot and wet, and that will be your typical, will be your what? The one that you use in the lab.
Autoclave.
Autoclave, very good. So here it uses high temperature, 120 degrees Celsius, and high pressure of 15 psi, minimum 15 psi. And you leave it in that condition for about 15 minutes, okay? But there is also cold sterilizing, and where you are going to expose it to ethylene oxide. These are gases. Because if you are going to use high temperature and pressure, they are going to die. So I don't know where that is, but somewhere it should be.
No, there's the autoclave.
Yeah, autoclave is here, but what is cold sterilizing?
That's all heat.
Okay, so here pasteurizing. What is pasteurizing? What's the difference between autoclaving and pasteurizing? Pasteurizing is not going to get rid of endospores. Keep that in mind, okay? You are just going to heat shock. Ultraviolet and ionizing radiations, you should know what they are. Not that I'll be asking you, but you should know that if whenever you're using this thing, ionizing radiation, you measure in terms of grays. All right, filter sterilizing, you have filter sterilizing, that's very common. This is going to be important. This is going to be important. So here, any substance that you use that is going to cause the lysis of the cell and decrease the total cell count, it will be called bacteriolytic. You just need to know to understand the word. But if you are just going to keep the bacteria unhappy, because remember we just said that, right? That they will go into stagnant phase and they will not multiply. We just did this, right? Toxin, antitoxin module. That will be called a bacteriostatic. Again, if you remember the word static, you will be able to understand. Okay. Now, this is important. What is the difference between antiseptics, sterilants, disinfectants, and sanitizers? You know, basically, this is something that you should just know the definition. All right. We did not talk about MIC, but at least because you are an educated being, you should know what is MIC is, minimum inhibitory concentration. So something which is best, which is decreasing the concentration. That's it.